So lesson 2, significant digits. And the question I have for you is, what's the difference between $600 and $599.87 besides the obvious 13 cents difference? Well, one value is more precise than the other. In fact, if someone says it costs $600, I'm fairly positive it doesn't cost exactly 600.00. I'll bet you that's an about. Whereas if someone says it costs $587, I'm fairly sure probably it was exactly $587. One is more precise than the other. Scientifically, we say that one has more significant or relevant digits than the other. We call them significant digits or significant figures or Sig Figs for short. And to give you the rules in English is very confusing. What I'm going to do instead is show you a bunch of numbers. I'm going to tell you how many Sig Figs, and I'm going to see if you can kind of spot the pattern, and then we'll write the rule out in English. I used to give the rule first, and I would see kids' eyes just glaze right over. So we're going to try it the other way. 600 has 1 Sig Fig. $599.87 has 5 Sig Figs. Put your pencils down, look up. $310. Let's change colors so you guys can see. It's a little darker, Mr. Dueck. 310. 2 Sig Figs. 4,500. Anybody want to guess? 2 Sig Figs. 4,530. 4,503. The same numbers, but I flipped the 3 and the 0 around. 4. So the first rule you're noticing is we don't count trailing zeros, the zeros that appear at the end of a number, what we call placeholder zeros. Because there was no need for me to write that 0, we assume that the reason that I did write that 0 is that whatever I was measuring was actually 1.6, and then I measured even more accurately, and I said, oh, that last number is a 0. So we would say this is 3 Sig Figs. The front zeros that are placeholders we don't count. The trailing zeros that are placeholders we don't count unless it's after a decimal. Then we assume the reason they put those zeros there was those were actual measured values. In other words, if I said to you that I measured something and I got an answer of 1.3000, there's no reason for me to add those final 3 zeros unless I had an instrument that was accurate enough to measure all the way that accurately, and that instrument happened to read 000 at the end. We would say that this has 5 Sig Figs. Let's go back to our notes, pick your pencils up. Rules. Any non-zero number counts. 4, 5, 6. How many Sig Figs? 3. 0.9723. 5 digits. How many Sig Figs? 4. Zeros to the left of a decimal count. So one I have here is 690 point. And one I have here is 690. No decimal point. This has 2. By putting the decimal point after that 0, what I'm saying is I actually measured that 0. That's not like me rounding off. I added that decimal to let you know that 0 is important. That has 3. That has 3. Zeros to the right of a decimal are tricky. If there are non-zero numbers to the left of a zero, they count, otherwise ignore them. Say, what? It's easier to show you the pattern. 67.004. 67.0001. 6. I can't count. 0.00035. 2. 0.00305. 3. 0.008900. This one's tricky. This is 4. We ignore those ones. We say you must have written those ones for a reason. Otherwise, why would you have bothered adding those? That must have been measured values. So that's how to count how many sig figs. Now, there are rules for multiplying, dividing, and adding sig figs. And the reason is this. Unfortunately, sig figs in Physics 11 are going to be fairly useless. I'm going to teach them to you. And even in Physics 12, they're not going to be that useful. They're much more useful if you take science in university and you're using good equipment, because any piece of good equipment is going to have an accuracy measurement on it. So you're going to be using a scale, and it's going to say that that scale is accurate to plus or minus 0.01 grams. At the same time, you're going to be using a ruler, and that ruler is accurate to 0.1 centimeters. And at the same time, you're going to be using a stopwatch, and that stopwatch is accurate to 0.01 seconds. How do you compare all those? How accurate should your final answer be if you're using those 3 instruments to get a measurement? And the answer is you use the rules of Sig Figs. These are the rules that determine, if you're publishing, if you're doing an experiment, how accurate you're allowed to be and how much of the rest is just garbage and you can't actually say that you measured that accurately. I don't have fancy equipment with tolerances written on it. Our stopwatches are going to be you starting and stopping with your thumb, and that alone adds a huge amount of error of human reflex time. So, kid, I'm going to show you Sig Figs, but really out of context. I'm going to emphasize it in this first unit. It's going to be on your first test. And then for the rest of the year, I'm always going to refer to it, but I'll never take marks off for it. Okay? That's my compromise with my nerdish self and my lack of $1 million budget. Oh, and now I know how big $1 million is. I'm visualizing a stack of pen. Okay, anyways. Multiplying and dividing with Sig Figs, formerly known as rounding off. First of all, you need to get your calculator out. If you don't have a calculator, Wednesday I'll be keeping you in after school if you don't have one by then. Oh, and a good calculator, not a cheap. Just saying. First thing that you do is you actually do the math. So 6.74 times 2.0002. You don't do any rounding off before you go to your calculator. And hit equals. The answer is not 13.481348. That's what your calculator says. If you were doing an experiment and you were comparing those two measurements, how many Sig Figs in your final answer? As follows. Thomas, my friend, how many Sig Figs in the 6.74? How many Sig Figs is that? Yep, you're right. How many Sig Figs in the 2.0002?
4, 5.
What's the fewest number of Sig Figs that I've just written down? What's the smallest number that I wrote? I'm going to go to 3 Sig Figs in my final answer. So, you ready? I look at my calculator. Watch. 1, 2. I'm going to stop on the 4, but I need to decide to round it off properly. Will it stay a 4 or will it become a 5? And how do I know? It becomes a 5 because what's next to it is n. So the whole rounding off, if it's 5 or bigger, you bump it up. Otherwise, you'll just leave it. So these are the rules for rounding off with actual measurements. These are the Sig Fig rules. I would say the answer is 13.5. I would go to 3 Sig Figs. Multiplying and dividing, you go to the fewest number of sig figs in your data. Look at B. Before I even get started, how many sig figs will my final answer be? 2. Let's actually do the math now. 6.4 divided by 9.088 equals 2 sig figs. Are you ready? 1, 2. I'm going to stop there. Is the 0 going to stay a 0, or am I going to round it up to a 1? Well, what's next to it? 4. So does it stay or get bumped up? And this is why I have to put that 0 there, though, to show that it is 2 sig figs. And that's why that's defined as 2 sig figs. That's why we said that zeros on the end after a decimal matter. So rule 1, you don't round off before you go to your calculator. You only round off after all your calculations are finished. Rule 2, you round off to the smallest number of significant digits represented. Okay? Try on your own what you think the answers are. For example, 1, 2, 3, and 4. I'm going to freeze the screen. I'll do them here, and then when I'm done, you can look up and see if we got the same thing. To the correct number of sig figs. There's what I got. See if you get the same as me. Let's move over so you can get it all on one screen. First one, I went to 3 sig figs. Example 2 across 2 sig figs, so it became 75. Example 3, Kyle, is also 2 sig figs, so 68. Example 4, that 5 means the best I can go is 1 sig fig, so I wrote the 7, but I've got to put the placeholder in the 70. And that's why zeros after a number, but before a decimal, so not on the other, on the left side of the decimal, don't count as sig figs. Is that okay? Multiplying and dividing is the, I'm not going to call it easy, it's the easier sig fig rule. Adding and subtracting, a little more difficult. In fact, adding and subtracting, I generally don't do in my head. I have to rewrite the question. Sorry. You may get good enough to feel comfortable doing it in your head. On a test or a quiz, I'm still not that comfortable. I'll always rewrite the question, and some of you are cluing in to turn the page. Excellent. Adding and subtracting. Okay. To do this, Justin, what you first have to do is line up the decimals, the decimal places. If they didn't do that for you, it's worth rewriting it. Okay? And then I want you to look with me, look up, folks. I have digits here. I know both of those. I know both of those. I know this is a 6. Do I know what's here? So all of you with your pencil, just put a little question mark right there. I have no idea what's there, and put a little question mark right there. Go to your calculator and type this in. Remember, we never round off before we go to our calculator. 4.567 plus 9. 0.0 isn't going to change the answer, but you can type the 0.0. Okay? So I get 13.567. I'm going to write that down underneath. keeping my decimal point lined up. 13.567. The rule for adding and subtracting has nothing to do with how many sig figs your original data have. By the way, how many sig figs does that top number have? 4. How many sig figs does that middle number have? 2. 9.0. 2. Okay? That has nothing to do with how many sig figs I'm going to go to. Spencer, you'll notice I know everything in this column. I know everything in this column. This is the first column where there's a mystery number, so I'm going to round off to that column right here. You round off as long as you know every number in that column. You keep it. As soon as you hit the first, I don't know what's there, stop, you round off one before. In other words, I'm going to go 13.5 or 6. Okay? And you'll notice, how many sig figs does my answer have? 3, which never appeared anywhere in my original data. So different from multiplying and dividing. I'll be honest, if they give me addition in a straight line, I have to rewrite it vertically, lining up the decimals, and then I can do the sig fig thing. But Alexa, I'm really not that good at doing it to try and keep part of the decimals. So here's the rule. Use all your known digits in the calculation. Don't round off before going to your calculator. Round off to the last decimal place that both numbers have in common. Round off to the last decimal place that's not a guess. Okay? Let's try one. Right here. 12.649. 7.3518, and you'll notice how I'm keeping the decimals lined up. And 12.41. Oh, heck, 12.4. Where am I going to stop? Can you see? Oh, change colors, Mr. Dueck. Can you see, Kyle, right there? That I'm going to round off to this column because there's my first mystery. I have no idea what came after that. I'm going to go to my calculator, and I'm going to go 12.649 plus 7.3518 plus 12.4, and I get 32.4000, sorry, 32.42 zeros and an 8. This is what I'm going to round off to. Is the 4 going to stay a 4 or round up? Stay a 4. Final answer, 32.4. So this one was to 3 sig figs, and one of my numbers was to 3 sig figs to begin with. Kyle, that's a coincidence. Adding and subtracting is, to me, far more difficult. Multiplying and dividing, I can almost do that in my sleep. Adding and subtracting, it's more work. What's your homework this year? You can finish that probably in about 15 or 20 minutes in class. You're not going to get more homework. I'm going to go check on my Science 10 class that I'm no longer teaching. Then I'm going to come back. I'll give you about 15 minutes, and I got a couple of cool videos to show you as well. And I'll also get my new students caught up.